by partial fraction decomposition. We have a bunch of different ones here. So for letter A, we're doing the integral from 5 to 10 of 3x plus 11 over x squared minus x minus 6. So what you should determine is a couple different things here. This is definitely going to be partial fractions because our numerator is of a lower degree than our denominator, and it's not in the form of being exactly the derivative of the bottom, or else it would just be a natural log. Also, the bottom is factorable, so that's even better. So this is 3x plus 11 over x minus 3 x plus 2. So we know we can decompose that into a over x minus 3 plus b over x plus 2. So we know that 3x plus 11 has to equal a times x plus 2 plus b times x minus 3, doing our common denominator and getting our partial fractions. So you can see here, this one's simple enough to do just by plugging in a couple of numbers for x. So if x equals 3, over here we get 20. Over here we get 5a, and our b's canceled because that was the whole point of picking 3, is that this would go away to be 0. So we can see that a equals 4. By choosing x equals negative 2, in order to make this one disappear, so we get 5 on the left. On the right, we get b times negative 5, so negative 5b. That tells you that b is negative 1. So we figured out our partial fraction decomposition. So this integral just becomes from 5 to 10 of these two added together. 4 over x minus 3. And instead of putting a negative 1 on top, I'll just subtract that one. 1 over x plus 2 dx. Okay, so now each of these are simple enough to do. These are just natural logs because our derivatives of the denominator is just 1 in each case. So we don't have to do anything special. This is just 4 ln x minus 3 minus ln x plus 2. We're evaluating this though from 5 to 10, so we do need to plug in also. So when we plug in 10, we get 4 ln 7 minus ln 12. When we plug in 5, we get 4 ln 2 minus ln 7. So we can use rules of ln's to make these a little bit simpler. We're going to get 4 ln 7 plus ln 7, so we have 5 ln 7. ln 12 can be reduced to ln 4 and ln 3, and ln 4 can be even further reduced. So what we're going to get here is minus 2 ln 2 minus ln 3. That's the same thing as 12 if you use your properties of logs. Remember that a number that's a product can be split into 2, and then if something is one number raised to a power, the power can come in front. Minus 4 ln 2. Minus 2 ln 2 minus 4 ln 2 will give us minus 6 ln 2 minus ln 3. So that would be as broken down as we can get it. 7, 2, and 3 are all prime, so we can't break those ln down any further, and that would be our answer.